Hello. Oh my goodness. Oh man, that should not be monitored. So I'm in the old setup. Wait, I'm in the old location with a slightly new setup, and so it's been fun. I got all my OBS stuff set up, and then I tested the microphone, and the audio quality was trash. And I've narrowed it down to I use a Blackmagic capture card. It's a by four input. It takes four 4K inputs, and however OBS talks to it and RTX voice talks to it, if you use it as an audio source, it's garbled. But if you use the audio on the video channel, it's fine. And it's funny because for the 3 years that I used this same hardware in the old lab, or the old setup, I could never nail down what the problem was. And so I finally found it. I don't know how to fix it, but I found it. So anyway, how's everyone doing? Hi, I'm James. Okay, here's what we're going to do tonight. I previously showed off the CERBERUS. This is oh, you know what I forgot to do? I can't believe I did that. Sorry. This is not going to be the first time tonight where I say I forgot to change something. I need to go to this one, right? No, scene, zoomed, scaled, and then do, excuse me. Okay, transform, rotate 180. There we go. And then on the zoomed, it should be correct. And it looks like it is. Okay. All right, there we go. That makes much more sense. The bot's been sleeping for 2 weeks. Okay. Yeah. All right, so this is the CERBERUS. This is a, make sure I point to the right chips. So this is a 6502 and a Z80 built into the same computer, or same board with 3 CPLDs to basically manage both video and then who's talking to the bus. Over here is an expansion slot for the for like cards or whatever you want to add on. And what I designed, or what we designed on a stream a couple weeks ago, was a board that will plug into this so that we can connect a digital discovery, kind of like we did in the Mega 2 project. I also made a generic one, but tonight I'm just going to try. I have tempered expectations. Oh, I hate how that. Okay, whatever. Anyway, so yeah, so the idea is going to be we build it. Let's see, which one is this? Yeah, I'll be able to plug it in, plug that in, figure something out. Okay, so that's what we're gonna do. We're gonna solder those up. Assuming I get the digital discovery one to work out, then we will probably set that up in waveforms because that's pretty easy to do. So I have this super big pet peeve with picture-in-picture. What I hate is I'm over here, and so my face is naturally pointing off screen. And that drives me crazy. But if I put myself over, oh, that's broken. Nice. But if I put myself on the other side, then you get the unnatural cut of the camera. So I'll deal with that later. Okie dokie. Let's go for, let's see, this is I did also notice this right before stream, and I'm really disappointed. So I ran these through OshPark, which I have a high expectation for. However, one of them, which one is it? One of these did not come out so good. It has a blemish, yeah. So this board has a, like part of the solder mask is missing. And that's on one of the ones I want to use too. So yeah, so this should be the same thing. Yeah, you can see, oh, this is missing some of it too. I better check the Gerbers then. Because that's, I mean, it's a different pattern in both, but in both spots, they, oh, wait a minute. Don't tell me. If I put my finger right here, yep, okay, gotta fix that, because that's gonna drive me crazy. Overhead scale, transform, edit, Nope, wrong one. Zoomed, transform, edit. Where's the rotate? Oh, okay. Gosh, I hope this is in the right place. 180, and it is not. But then I might be able to just do this. No. All right, so it needs to be, this probably has to be, what's 119, 19, 20, 40, so 38, 40. And then this would be 2160, and that should be correct. All right. All right, let's try that one more time. Unzoom, put my finger on the thing, and it zooms to the exact wrong spot. Oh, goodness, 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 goodness. Zoom. So it should be right there. All right. So that's like over here somewhere. And then if I edit that, maybe this wanted to be at 2880 and 1620. All these numbers make sense to me somehow. All right, and then we're gonna get out of studio mode. Go here. Okay, fixed. All right, anyway, let's get soldering. So what I wanted to make sure, this is the DD, this is a DD. I will put these next to each other and then try to remember to come back and get the frame for this, because I do want to send that to Osh Park because that's kind of annoying. Yeah. So do I have a card in here? Hold on. Why don't I just grab an SD card and take a picture real quick? That'll work. I have a third board, but I lost it, so oh well. All right, so let's do, this card is write protected. You're write protected. Oh wow, this card is toasted. Never mind. Yeah, funny thing. After doing video for, now that I've done video for like over 10 years, my SD cards are starting to fall apart. It's crazy. Who'd have ever thought? All right. Cool. Okay, let's get to the soldering part. So I'm going to go with this one. That really worries me, actually. What's worrisome is I don't remember. Oh, wait, maybe I made the whole bottom ground. That's why I'm thinking. I mean, it still bothers me because that's, you have to make sure we don't short that out. All right, so bring this all the way up. I'll handle the focus here in just a second. Let's try. So which side do we want to do first? I tell you what, the easier side, well, the easiest side to solder first is going to be the this side, because I've got those right here. So this should plug in, and these are the same ones I used on Mega 2. So that should work no problem. Now, one thing I was going to try is I am going to try putting it in upside down, because I'm hoping that, well, I've got two reasons for it. One is I'm hoping that it will keep the Digital Discovery's profile lower so that it's closer to the table. And second is on the other side of this board, you'll be able to actually see the signal names. And so, is this the right one to look at? Yeah, it's this one. And then this one is not the DD, correct? Correct, that's a 1-to-1. Just want to make sure I've got what I think I have. I do have 3 DDs. Okay. All right, well, we're going to solder this one because this one doesn't have the same defect as the others. It almost does, but yeah, let's go with that one. Hey, Squire, good to see you. Okay, so this we will put into here. So that's the easy one. The not so easy one is the 40 pin, because I don't have, well, wait, what type do we need? I already forgot. So on the Cerberus, it's a male pin, or it's a pin instead of a socket, however you want to say it. So let's see, what can we do? Now, one option would be we just make this with, we make it so that you can just use a ribbon cable, which I sort of like that idea. That's of the options, that's probably my favorite. However, I was going to look and see, do I have, so what do we need? We need sockets. So I have a 2x32, and that's going to end up going on here, I think. And then that would leave 1, 2, 3, 4. But I don't have a 40-pin socket. I'm quite certain of that. Is this a 2x4? Oh, wait a minute. Maybe this will work out just fine. Oh, these are going to be different heights, aren't they? Or it's just slightly too thick. So that's not going to work. Let's try this. So then, so I could probably shave those down. Yeah, I could probably shave them down a little bit and get them to fit right next to each other. But are they the same height is the question. They're even the same height. Well, that would actually work. I want to do that. So I'm going to go get some sandpaper. I'm actually going to sand this off screen because disconnected audio makes for better streams. But yeah, I'm just going to sand the edge of both of these on some sandpaper because we just need to get rid of a little bit of their width. And I don't want to bring my sandpaper over there because I don't want all the dust and stuff to get all over everything, because this is a completely different part of the lab. You've never seen this part of the lab before. Well, I mean, unless you've been to my house, in which case then you might have seen it. Okay. So that will fit there. And then that will fit here. If I can get it to fit. That's not enough. All right, who's got more to give? Well, I'll just keep doing them both. Fine, I'll just bring the paper over. No, I just don't want to make a mess. Maybe I'll just do this really, I wonder if I need new sandpaper. What side did I sand? I should have marked it with a marker. Maybe I'll do that before I walk back over there. Oh, you know, I just realized you probably can't even hear the sanding, can you? Because I'm using voice RN or noise RN, which does a pretty good job of getting rid of everything but voices. Okay, let's try that. I don't think I even need to mark it anymore. It's way more obvious. Okay, what does this show? Dun, 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 dun. Come on. All right. No, we're almost there. I'm getting just a smidge of resistance. I'm going to try something first. Will this plug into here? Yeah, I'm really mad at myself because I did not think to order. I ordered a bunch of parts, including Z80s, and I didn't think to get a proper header. Okay, I'm going to solder this first. So, because we actually have a decent connection. Oh, autofocus? No. That is a no, sir. You are not, no. No. Not gonna have that. No, sirree. All right, so now bring this over here, clean that. So the way I designed this is, so the logic analyzer will be plugged in on this side, and then we can put a header on this so you could actually plug something in. I don't have any I don't have anything to plug into this, so I'm not really worried about that today. I just want to be able to use the logic analyzer to see the signals over here. So that's the goal. All right. So what I'm going to do now is I got a little bit of solder on there. I'm just going to make sure that everybody's happy. Now, since I am in situ or in situation, I'm going to try to go a little bit quick because I don't want to melt anything. And I'm going to have to do this because totally because my eyesight is perfectly fine and there's no issues whatsoever. Oh, that's so much easier. All right, let's get that one and that one and that one and that one. And then I think what I'll do, I'll add on my next parts list, my parts order. I will get proper 40-pin headers for these. I thought I had them, and I'm not sure why I thought I did because, well, actually I know why I thought I did, but I don't have sockets. I have headers, but I don't have sockets. So, like, I think we could put one on that side, but I'm not going to just because I don't want to build up. I don't want to waste my connectors, and I only need one of these anyway. There we go. All right, let's come back here and try to get a couple of these grounds. These I will do at the moment, like right away, because I want to use the residual heat since they are a heat sink. Well, so I've been trying to, and I'm trying to think of an example. I'm looking for a board to demonstrate why you want to do this. So for the longest time, I told people, put a ground plane on both top and bottom. And the more and more I think about it and the more and more I read about it, that is really not a good idea. Now, I think for the vast majority of like hobby level boards, it's probably fine. But it's one of those things that my initial attitude was it's better to do it than not do it. And I've started to realize that it's probably better to not do it. So I do think, I mean, like in the case of this little adapter, the bottom side or one of the sides is all ground, minus a couple of signals like around the edges or something. But I did not fill in the top where most of the traces are with ground for two reasons. One, because it's a straight through, for the most part, it's kind of a straight through. So it would have required an enormous amount of vias to connect the top and bottom together. Because the one thing you don't want to have is isolated or ground orphans. Is that the right word? Because then you have the potential for two pieces of that ground plane to be at different potentials, which on a low speed circuit is not a big deal. But on a high speed circuit, it's a problem. And for EMI, it's a problem. All right, so that kind of works. And then since mine isn't keyed, I'll have to actually pay attention which way this gets plugged in, but it should just go in like that. Okay, well that was easy. Oh, I don't have any of the stuff set up. Nah, I will work on that for next week. Yeah, because we actually I have another project. Well, actually, what I'll probably do next week is I would like to actually do a little bit more stuff with this whole setup. Or I have a whole nother set of boards that I want to start populating, and we might just do that. They're my power supply or my bench power supply adapters. I have them now for USB-C, a barrel jack, and a screw terminal. And I'm really excited to put those together. But I didn't want to do that today. I wanted something a little bit easier. It's been a long couple of weeks. There we go. Okay, let's see how that looks. So what I want to check on this real quick is just make sure that, yeah, it's kind of crooked. So what I'm going to do is I'm going to heat up this side. And, oh, let's tighten that down. I'm going to heat up this side and ever so gently push it down and heat up this side and kind of let it naturally, yeah, I could feel the release. Let's see if that's, yeah, it's still a little bit off, but that's probably as good as I'm going to get. Let's just go with it. Okay. So the whole idea of this adapter is that I'll be able to take a digital discovery, which is it's like an analog discovery or the analog discovery 2, except that it's a purely digital device. And so it is a logic analyzer. It samples much higher, much faster than the analog discovery. And you can do up to 40 signals, I think. What I do know for certain is you can do less signals than I thought you could, because when I did this for the Mega 2, I thought you got to use all, I think there's, let's see, there's 32 plus 10, 42. I thought you could sample all 52, but I think you may actually be, now I'm saying all these numbers, I think you're limited to 32 channels, which seems like the correct number. Whereas before, I thought you could do 40 because of the way the headers are laid out, but I think you can only do 32 total, which in retrospect makes a lot more sense. So, all right. I lost my alternating. I want to do the grounds last just because ground sucks up so much heat. I'd rather do them together. All right. I'm just trying to move around the connector. And I'm not going for world's greatest solder joints, because if I ever did that, then I would never finish. All right, that looks pretty good. That's looking pretty good. That looks all right. All right, so that all looks good. Okay, so then we got to figure out what we're going to do with this one. Did I pull something out for that? Because that's a 2. Oh, this is the same problem I always had with Mega. I don't have a 2x5. I only have like a 2x5 straight header. Which may actually be the right thing to use today. Where's my other box? Let's look in here real quick. I do want to use a male header on that one because it'll be easier to connect the flying leads. But that might work. I wonder if I have a 2x5. That's a straight header. That is whatever those are. That's a by 1. That looks like more by 2s, but those are straight. By 2 straight header. What I was looking. Oh. No, those are for ISP, aren't they? How many do I need? I think I need 10. What do I do with the thing? 1, 2, 3, 4, 5. Yeah, 10. Yeah, because it's like 8 signals, 2 grounds. Okay, so I think what we can do is take these by 2s. Should be able to cut up one of these to be usable. Oh, I meant to put that away. These can go up here for now. So do I might already have that's 2, 4, 6. Come on. 2, 4. This one's 5, but it's missing 1. This is 1, 2, 3, 4, 5. Okay, that one is 6 missing 1. So that might be the easiest to turn into a by 5. That's only 4. Got those already. Okay, let's do that. I'll leave that one out because that'll be a backup plan. All right. None. Okay, so I need to cut off that. Oh, that's right, I moved everything. I should put my glasses on. Okay, I'm gonna just use safety squints after I start to squeeze. Let's try right here. Yep, I can still see. Let's try that one more time. Yep, I can still see. 2, 3, 4, 5. Okay. Bring our board back. And so let's see now. What would make the most sense? Would it make more sense to plug this one on this way? Or do I want to go this way? Because if I'm upside down, then... Nope, I already know. I want to go this way because I just thought of this. I just realized something. If I plug the logic in, yep, okay. After all that, the problem is if I plug the logic analyzer into this, then I can't get to those signals. So they have to be straight headers. Oh, goodness. All right. Well, in that case, we'll use these. All right. So they're going to have to go on this way. And then these are going to be a little bit of a pain because they're like, they have really short pins on the business side. So what I'm going to do is we're just going to, yeah, here's what I'm going to do. We're going to put some solder on here. All right, turn this slightly. And then I'm going to bring this around here and gently nudge that into place. Okay, let's see how straight that is. Yeah, that's going to work just fine. All right, and now we'll get the other side. Yeah, actually, it's funny. I realize now when I was doing the KiCad, the 3D renders of the PCB, I remember thinking that, oh, that's not going to work. So I just forgot. Because I think in my renders, I have that as a straight header. All right. All right. And then, oh no! What? Oh wait, no, dummy. The pins don't come all the way through, and I thought I thought we didn't. I thought I did a 2x8 instead of a 2x5, or yeah, 2x5. Whatevers. I guess the good news is instead of buying new parts, I'm just using up parts I already have. So I guess there is a positive to not have, you know, like I keep looking at these like it's obvious that they're wrong, but I didn't have to buy anything new and I'm not probably ever going to use them for anything else. So, okay, so now I want to do 2, 3, we need a couple of by ones, which I might have, what do I have in this box? Yeah, this box might have what we need. So we need one of these. Can I do them all in gold? So I need a 2, and a 3. Okay. So 1, 2, and 3. There we go. All right. And then these can all go back in here. Hey, that's in the wrong one. That's a test header. That shouldn't be. Oh well. That's a problem for future James. Okay, so same sort of deal. So on here, there's a pin. So this header over here, this is just going to be for plus or minus 5 volts, more or less, just to, you know, maybe I'll use it for the multimeter or something, just to make sure that it's actually connected. I also have an idea to build a to build a 5-volt adapter for the digital discovery. One of the issues I ran into on the Mega 2 using the digital discovery is its voltage threshold is it's static, and I think it's at 1.8 volts. And so it works really, or it's designed for 1.8 volt CMOS logic, which is fine for up to 3.3 volts. And for the most part, it's okay for 5 volt, except that, and in 5 volt TTL parts can bounce around around their negative on the low side. Their threshold is within the high threshold of the logic analyzer. And so like on the Mega 2, we would have to sort of ignore certain glitches because they weren't real. Like, I mean, they were really occurring, but they weren't actual logic glitches because the logic of the Mega 2 had a different threshold setting. Or, yeah, I'll say setting, that's not the right word. So anyway, I've thought about how to, so I made a prototype of an adapter that's basically, I think it's 245 latches. It's either 245s or more 573s, but it's an LVC part so that you can basically, it'll output 3.3 volts to the digital discovery, but it'll accept 5 volt signals coming in just as a way to try and clean those up. I have one, and I think I've even built it, but I don't think I've ever tested it. Like, I got the boards made, and I think I built one. Might actually be an Adams video someday. I don't know how I'm going to do this. I can't see it. Yeah, I mean, it's one of the, so for the most part, it's not a big deal, but man, if you're trying, I mean, well, when it's really a big deal is when you're trying to trigger on something and it keeps false triggering. That's the, I can't make this translation. Okay, I should have just done this. I already know the better way to do this. I'm just going to turn this up like this, right? Yeah, and then that way I can just come and hit it on this side because then I can see it. My brain can figure out how to move my hand this way. Come on, maybe. Let's go ahead and get this melting. There we go. All right, boy, that's really messed up. Okay, how's that gonna look? Well, Squire, if you make your adapter before I finish mine, I will gladly use yours. Because yours will probably have the added feature of working. But yeah, like one issue I thought of is that you need a 3 volt power supply. So what was I thinking? Yeah, so like in this case, my plan was use these 5 volt pins to take 5 volts from the board, the target board, use a linear regulator to get that down to 3.3 to work as a reference for the LVC, well, reference and driver, but same idea. Okay, so now that we're halfway on, now this next bit of this next header, its purpose is to either detect the state of the latches, buffers, or to give you the option to drive the buffers from the board. And so I'm going to do it as a 3-pin that would support a header, but really you should never need to do that because the target, why'd you fall? I hate by one connectors. I swear, as soon as that container is empty, I'm going to go to surface mount. I don't want to waste all the money I've spent on these things. Or I'm going to find out what kind of glue you can use. All right, well, turns out if you move your hand fast enough, you don't get burned. And that's straight enough. All right, so then I can just do this now. Alrighty, let's make that happen. And it wouldn't be a me project if I don't burn the connectors I'm working on. Jeez, every freaking time. It's almost like I didn't plan ahead. Okay, so there's our board. Now let's do some cleanup. So let's grab this, take this stuff out. Oh, trash can, what are you doing over there? That's no fair. Oh, come back, come back, come back. All right. Let's go one of these, one of these. We need some of this. I need a couple more of those. One more will do. And a brush. All right. So we'll just do a quick application of IPA, the good kind. Yep, that looks good. And then we'll come over here, clean that up. That looks good. All right. I can already see there's a couple joints that aren't great, but I think we're going to move forward anyway. I think it'll be, well, that pin is completely missing. Whoops. All right. Let's clean up this side. Really, I just want to get the grossest part or the thickest part of the unactivated or the flux residue off. Remember, no clean doesn't mean you shouldn't clean it. If completely burned properly, then no clean will be inert. The problem is when you're hand soldering, your process is not very well controlled. And so what gets left behind is not always inert, as we have learned multiple times. This one is still kind of nasty. Let's try this. There we go. There we go. All right. Okay. So now let's clean that up. I don't like that one either. Or this one. Or this one. Or that one. I see a little bit of gold. All right. This ground could use another hit. That one. That's probably where I put the iron last time. Okay. This one. Yeah, a little better. Okay. Then on this side. Yeah, this side is in much better shape. Okay. Cool. Sweet. Now we can connect this to the logic analyzer and see what this little board is doing. Oh man, I'm gonna need a power supply, aren't I? I just realized that. Oh well, we'll figure it out. All right, cool. So here's what I'm gonna do. Let's do a couple of continuity checks just to make sure that we didn't short anything. Well, just make sure we didn't short power and ground. All right, so ground, yep, 5 volts and ground, nope. Okay, that was the one I was most concerned about. And now, let's see. So the idea, let's get this. I'm gonna tin my iron before I turn it off. Okay, plus it makes fun smoke. All right, we'll shut that off. We'll roll up the solder. And then move this out of my way. And then kind of move these things. What am I gonna do with all this stuff? I need my little dishes. I don't know where they're at. Oh well. Okay, so we'll put that over here. Yeah, right. Except the Z80 doesn't go burr for much longer. Oh, that's cool. Oh, you know what's funny? It's keying out the, it's trying to key out the multimeter because it's green. All right. Okay, so, oh, you know what we didn't put on? Okay, I'm not gonna bother. I had pads for an LED, but I don't feel like doing that right now. All right, so we're gonna, yep, that's gonna go, which would probably be good to know because then you would know if you put this in wrong. All right. Okay, so that goes on there. This will plug into the Vijaya port, which according to a video I made said is a modern interface because it fit my narrative. All right, and then that side's going to plug into this. Okay, I need a new cable. Is that, which one of these is the 3-foot? That's what I want. So I just want to turn this on and make sure that it's actually functional while my board is connected. So that's what we're going to try to check out now. So yeah, so I want to do something like that, and this will plug into my capture device. All right, so hey Genius, how are you going to power that? That's a good question. I think this cable won't work. Where is the cable I was using? There it is. This cable is what I used last time. All right. So now I'm going to try plugging that into Mr. Power Supply. And if this works, we'll hear a dun da da dun. If it doesn't work, then I don't know what I'm going to do. All right, I don't know if noise suppression caught that, but we're going to do one of those. Okay, so let's do this, do that, close this. I'm going to open up the OBIS, and I think I'm not connected to the streaming computer, so let's get that going so you can see what I see. There we go. Let's do a remind me later. Alt F4. Let's do, all right, so now I can go over to here. Oh, it's still connecting. Okay. Oh, I don't want to capture that. Also, no, it still hasn't connected yet. That's a bad sign. But I don't need it to be connected. All right, kill that. So we want to do USB video capture device. Come on. Yep, that's the one I think I want. Oh, I gotta play this game. Oh my goodness, there's a green screen. Nope, not that. This one. There we go. Uh-oh. Oh, I forgot to power the VGA adapter. Okay, well that one's easier. I know where that cable's at. Let's go grab USB micro. What is the longest one I have? Oh, that's so much long. This is like all the long. Ow. All right, so we're gonna plug that into here. And then we're gonna plug that into here somewhere. Yeah, it's on the side. That's what I don't like about this one. It's very inconvenient. All right, so if we do that, and then turn on that, there we go. Yay, that's what we're looking for. Okay, so since that is working, Now we can come back to our overhead. I'm gonna disconnect power for now. I don't really want that. Oh, so close. It's almost flush, like just barely. Man, I was really, really hoping I got it. Yeah, because like if this is in the case, then yeah, that's not gonna, I need something under that for now. I got an idea. Let's grab a sticky mount. Just something to offset it slightly and take some of the pressure off the connector. Man, I was really hoping that was going to be close enough, but it was not. So let's see, let's try this one. Okay, that's not the most elegant solution, but it is a solution. Let's put one of these rubber feet on the back, and that it gives us enough offset that I'm much more comfortable with that connection. That's probably a little bit high too, but that will work for now. Put that down there. Go down there. I'll probably turn this off before I do something accidental. All right. Okay. So that's what we got. That's what I was going for. And now I need the USB cable for that, which oddly enough was the same cable I was using for the other thing, but somehow I'm missing it now. Come on, really? I'm not sure that I'm okay with us moving away from USB micro, only because I still have so many of each cable type just laying around. All right, I don't know if this is a data cable, and my tester isn't down here. So we'll see if this works. Okay, so let's go waveforms. Come back to the Lapa Tapa. Waveforms. Does it find it? Does it find it? Does it find it? I am actually no device found. You're no device found. That's dumb. Okay. So what I'm going to try then is I'm going to switch these and see if that works. Let's try that. Cool. And then over here, if I plug this back in, does this turn back on? Perfect. I like when things come together. All right, so let's let's open up Logic. Man, I forgot about this hub that I'm using for power. It's got either X7R ceramic capacitors or a bad coil, but it whines and I can hear it, which I think noise reduction usually kills it, but still, it's kind of like, really? I completely forgot about it, but I used to almost not be able to hear it in the old setup just because I was a little bit farther away from it, and the fans from the streaming computers kind of overrode it. Okay, so we're going to set up a bus, and now we got to figure out, oh, I should have done, maybe I'll add that real quick. Burr is in bus air. Hey, Francois, good to see you. Let's do studio mode, laptop scene plus overhead. Where is overhead? Scene. Let's do overhead scaled. Okay. And then we're going to scale this down to, what's the number? It's 1920 divided by 2 is 860 and 540. I think it needs to go a little bit lower than that. But let's see what that looks like. Yeah, what's the next step down? It's what's 1920 divided by 4? So is that 5? 1920 divided by, so 480 and 270. That's gonna work. Just to give us, so we can get an idea what's going on. Okay. There we go. And then this one, what I can probably do is zoom that. Oh, wait, why doesn't that work? So if I go to overhead and zoom, and then I come back to the laptop, it's not using the zoom. Oh, okay. Well, I know why that is, but I'm not gonna fix it right now. That'll work just fine. Because here's what I can do instead. Yeah. So what I'm doing is I'm looking on this thing as my guide. So 68,000 has bus error. So let's do address, X address, and we're going to use bit 23, and then bit 19. Boy, I don't like the way I did this. No, that's backward. Okay. We're going to go the other way then, because it's going to build from the bottom up. So what I'm going for here is, so I'm looking at the inputs of the digital discovery, which so 0, 1, 2, 3, 4, 5, 6, 7, 8. And then over here, I have the bits of the CERBERUS bus. So, but they're like odd, even. Basically, I just made it as clean of a layout as I can, because I figured this can just mux it all for us. So what we're going to have to do then is, so bit 15 of the address bus is bit 8 of this, and then bit 14 is 12. So then it should go 9 and 13. And then we'll go 10 and 14. And then we'll go, so 11, 15 are, wait, I can't tell. I'm gonna disconnect that for the, actually, this doesn't need to be plugged in yet. So 11 and 15, so 10 and 14, 11 and 15, 11 and then 15. Okay, we'll go ground. So then we'll go 16 and 20, 16 and 20, and then so 16, 20, so 17 and 21. I'm noticing a pattern. It's only taking this long. What did I just do? 17 and 21, so 18 and 22. Okay, and then 19 and 23. 19 and 23. Okay, so let's see. I'm not actually sure how I want to set the rest of these up yet. We're just going to leave them, but this is the order of the pins that I want. So it should go like 8, 9, 10, 11. 8, 9, 10, 11, 16, 17, 18, 19. And then, because then down here goes 12, 13, 14, 15, 16, 17, 18, 19. Yep, okay. I'm not a big fan of SIGROC, so I didn't even realize it supports the digital discovery. If it does, all right. So now we got to figure out where we're going to put this. I want to put it in the Git folder, but for now, let me just go to the desktop. Cerberus DB. All right, and then we'll just do Cerberus 2100 digital discovery template. Now, keep in mind, we did do a one-to-one logic analyzer adapter, which would work with any logic analyzer. I mean, this one would work with any logic analyzer as well. It's just I specifically laid it out for the digital discovery, which I do recognize a lot of people don't have, unfortunately. Logic analyzers are funny. They're good ones like this are getting less and less easy to find. Generally what you find is just something based on that Cypress chip that can capture 16 inputs at once and stream them over USB, which is fine for a lot of things, but they are pretty limited in terms of total capability. Okay, so now we're going to go 0, which is why one of the FPGA projects that I'm going to work on is a state mode logic analyzer, because it drives me crazy that we've completely lost state mode. Every logic analyzer you can buy today is timing mode. And in a lot of cases, timing mode is just wasting boatloads of memory and makes triggering more difficult. Whereas a state mode logic analyzer only stores the inputs based on a clock and qualifier from the target. So if you have, say, like a bus with a clock, you could say only store values after the clock edge. And that saves a ton of memory, and it makes working with the file with the traces so much easier. The downside is if there's any signal integrity issue, you may not see it because you're not oversampling. But arguably, logic analyzers are terrible for signal integrity. So, all right, so that's data. And then I want to see, will it let us add the clocks? So where are we at? We're at, so I really want the other set of inputs, I think. Oh, I did not think this through very well. Oh, wait a minute. So this will let me have 24 through 29, or these. Oh, man. I got bit by the same thing again. Yeah. Fail. So I put all the clocks and everything over here. And there is a set of inputs over here that start with number 32. But because of the way the configuration works, in order to use all 24 of these signals, you have to use this input. If you want to use this input, then you can use all of these and only half of this one. It's really dumb. It's really dumb. Yeah, I mean, I doubt that this would be supported by SIGROC just because it's not a direct interface. You have to load the bit stream. I mean, that's Waveforms reloads the bit stream for the configuration. So, shoot. I don't think, and there's not another configuration. Well, there's going to be a revision 2 of this interface. I'm going to swap. I'm going to swap these. This header should be over here, which actually makes things a lot more difficult now I think about it, but because this is just going to be kind of gross to connect. But okay, well, we got to go with what we got. So let's see. Well, let's go 24. and we're going to call that XE, right? I'm going to go 24, call that XE. Trying to think how I want to connect this. So when I fly this over here, I want to do it because I was thinking about building a ribbon cable, which would kind of eliminate this total issue. So yeah, so let's do it that way. So okay, I'm just going to do it this way for now. Signal, and then 28 will be X clock. I think it's called X clock on this header. I only had 3 letters I could use when I was doing the silk screen, but I figured people could figure that out. SLC, I don't actually remember what SLC stands for. Let's go 29. Rec. These are way shorthand, but that's okay. 26 will be IRQ, and number 30 is ACK. 27 is XWR, write, and then the other one's going to be read. 31, read. All right. That's going to be a pain in the butt. Well, no, I don't think they've documented how you load a bit stream. Why would they? It's not something they support, so I don't know why they would do it. Actually, one of my frustrations with going from the analog 2 to the analog discovery 2 to analog discovery 3 is they did actually provide all of the hardware design of the 82 as part of their documentation, but they don't provide that level of detail for the 83, which is really sad, because there's a handful of, I mean, like the way that they handle the input buffers and stuff could be useful to, say, somebody trying to build a state mode logic analyzer, but they didn't. But as far as like loading the FPGA and stuff, I can't imagine any. I don't think you could give them a viable reason to provide that information, because once, and I realize open source fanatics don't fully understand this, but there is a perceived liability that once you provide that kind of information, like if you gave the floor plan for the FPGA and how to load a bit stream, the company now has opened themselves up to liability to provide some level of support for that, and that's something that they don't want to do. It also backs them into a corner of, if they decide down the road not to do it, what do they do? And so I don't know. And if it was an ASIC, then never mind. I'm not gonna. Okay, so I need to get the flying lead adapter, right? Or is it? Do I have it in here? Because those I don't actually have many of. Yeah, perfect. Okay, so this is. Let's see if I can follow my own directions. So this is going to go to here, and this one is going to go next to it. This just kind of sucks. If it was right here, it would just be nice and pretty. I am going to make a ribbon cable then, because this looks dumb. Ribbon cable won't look that much better, but at least I'll feel better. Okay. Let's just keep going to here and to here. And then that's not right. How did I run out of wires? Oh, because I'm looking at the silk wrong. All right, let's get this one to here. And then I'm pretty sure VIO, we might actually have to connect those because that might actually be the reference. Or maybe that's only on the other side. Yeah, I'm just gonna, okay. Well, if I've done this right, then we should be able to get activity now. So let me plug this back in. And then let's save this one more time. And let's see what happens. All right, let's do a single run. All right, so a couple things. Let's do so I think we're running 8 megahertz right now. So let's make sure we're sampling at least 20 megahertz. All right, do another run. And then let's do like microsecond per division. Do another run. That's looking pretty good. All right, so then res fall 4 megahertz. Okay, so we're in 4 megahertz mode. Where's my keyboard at? I don't know if I can plug this in after the fact. I guess we'll find out. Okay, so come back over here and then let's go fast. All right, and then run this again and it is not going faster. Yeah, it's 8 megahertz. Okay, so we get the clock. Now, what we need is some kind of activity. So let's do this. All right, let's just do that and see. Okay, so, oh, I know what's going on. Hey, Bellum, good to see you. Def Palm, I totally missed your message earlier. Hello to you too. I totally know what's going on, and this is by design. Okay, so on this header, or on this board is a header, and it determines what happens with the XE signal. The XE signal is what enables the buffers on the Cerberus. Now, normally, if you had like a plug-in card, you would use that card to yank that down so that you could actually sniff the bus. I think it's active low, but I'm pretty sure it's active low. But let's go look at the. Let me think. Where do I have the? Let me pull up the documentation and then I'll switch back to my computer. I'm trying to remember where I put everything. Retro computing projects, Cerberus, GitHub files, manufacturing design. Where's the PDF at? I feel like there was like, oh, the hardware manual. Okay, I'm gonna go back over here. And then I'm gonna just search for XE. Match words. There we go. So that's the signal right there. XE enables the bus. Okay, but do you pull it? Is it active low or high? All control signals are active low. Okay, cool. That's what I thought, but I wanted to double check before we go do something. So I'm going to pull power. Let's go back to the overhead, and then I'm going to grab, since this is a blue board, let's use a blue header jumper. This is blue. That's not blue. And we will tie this to ground. There we go. And now we can plug this back in. And we'll go back to the laptop and we'll run one more time and see what happens. Okay, so now we see the bus is being held hostage at a high, right? Yep, that's what that looks like to me. So now let's go back and do our same basic program. I'm actually going to go slow, and then basic 6502, 10 print hello, 20 go to 10, run, and then, oh, look at that. There's things. You can see the things. They're right there. There's things. Things happened. Yay, we made a thing happen. Now, I have no idea what any of this means, but there we are. So, I'm trying to think. This is the 6502. So, I'm going to change something while I'm thinking. So, I think what I want to see, okay, I think I know what we do now. First, let's get this to be, let's do a window projector of the source. Oh, nope. Window projector of the source. Okay, minimize that so we can see it. If I click on this, yeah, okay. So let's do a Control C. No, what do you do? Escape. All right, and then I'm gonna hit F12 to go back to the BIOS. And there's a way to read memory on here, and I totally forgot what it is. List memory. Okay, so if we list at 2000, it looks like it's mostly empty, or not. It's not empty, is what I was trying to think of. So what I want to do here is, I don't know if you guys remember, but with the Mega 2, there was a bug with the triggering on addresses. So let's see if we run into that same bug again. Protocol X address trigger on. Well, okay. Double click this. I want this to be in hex, and I want this to be in hex because I don't know what decimal is. It's kind of like I don't know what Fahrenheit is anymore. All right, so then I want to protocol on here, and I want to trigger on, well, I don't want to trigger on any of these things. How do I set what I want to trigger on? No. No, why aren't you letting me define what I want to trigger on? Let me type it in. What the heck? That's new. Yeah, so oh. Okay, well that didn't work anyway. I'm going to try something else. List. Okay. Hmm. Hmm. I don't get this. Like, what is any of this? Why can't I? So you used to be able to just type in what the pattern you want it to trigger on, and now you can't. This, I wonder if it's because of the way I set up the bus, it won't let me anymore. Well, that kind of makes this completely useless. Download waveforms beta. So I've said this before, if you download the beta version of waveforms, you don't have to give them your email address. And these get posted very often. I don't think weekly is the right cadence to suggest, but it's pretty often. Yeah. I'm pretty sure I don't care. More info, run anyway. Need to disconnect it just in case it tries to update the driver. Although I think it's libUSB for some reason. Oh, yep, gotta do this. That looks fine. I'm really concerned with the way that trigger menu is, that trigger interface is set up, that this isn't going to work the way it used to. And if that's the case, then that makes this almost useless. All right, I'll plug that back in. All right, and then let's open up this file. Going to protocol address. Okay, there we go. Apply, okay. Run. And then let's do list 2000. So how can I do this? I want to see. Just run continuous, I guess. And let's see if we can figure out what address it's seeing. It's not seeing the addresses at all. Which, hey, Pete. Okay. I thought for sure this could still see reads and writes to I thought it could still see the reads and writes to the bus. So let's try, let's go back into basic. Interesting. Unless we're not able to sniff when reading directly from RAM. No, there is activity. What I need is I want to trigger on not FFF. I wonder, will it let me add bit 15 by itself? And I want to catch this on an edge. All right, so then I should be able to do list 2000. Okay, so let's go back, let's go to 0. All right. All right. Okay, so it is showing us stuff, but I'm still not sure that we're seeing when we're reading from the memory. And now I've got to do, let me come back over to here real quick. Sublime. Okay. I wonder if this is the same bug I had before. Right, because this would be 1010, 0100, 0011, 1111. So what if we reverse that? So it's 111, 1100, 0010. So that should have been, that would have been F. What's that? C 25. Okay. Okay. But if I look at this, so that's 6434F. Okay, let's do one other thing. Since I know that E43F is happening, let's just make sure we can trigger on that. E43F. Let's at least make sure that the pattern trigger is working. Okay. Okay. Is that what we actually said? Yeah. Okay. So that's encouraging. I'm still not convinced that what we're capturing is what I think we're capturing, but it's a step in the right direction. I'm thinking we're not able to see the reads and writes to RAM. So let me look and see if, where's the memory map? Here's another one. Does read ever get yanked? No, because this is the external read, so that would not get yanked. See here it says you can see video and character memory, but what you don't get, and this is somewhere in here it's saying this, is that you don't get to see the read and write signals on the other side of the buffer. But you should be able to tell what is going on if you watch everything else. So the top of memory is EFFF for the expansion, right? Okay, so if I said, so let's just try something. EFFF. All right, and then in here, what if I did a, how do you write? Well, we shouldn't have triggered on that. Why did we trigger? Oh, see, this is why I hate timing mode logic analyzers, because we triggered on noise. I'm trying to remember what the deal with DMA is. I believe you can DMA. The card can, but since I don't have a card right now, I don't have a way to initiate it. So what I'm trying to do, at least at the moment, is I'm going to write to the card that doesn't exist and see if we can capture it. So we do 03 FFFF and I send out an AA. Yeah, I don't have confidence that we're actually seeing it. what I probably need to do is qualify this with the clock somehow. Yeah, so just to back up, just to be clear, so what I'm trying to do at the moment is, so this is the Cerberus. I'm using the 6502 at the moment. It also has a Z80, RIP. And then over here is an expansion slot, 40-pin expansion slot. And so ideally, you're supposed to plug in cards or other peripherals to this. And so by enabling the buffers, which are underneath, they're like right here, you can enable the buffers, which allow you to sniff the address and data buses. It's just that you get a buffered copy of them. And so that's why I'm trying to, I just want to see if we could, like, what I was hoping to be able to do is capture, like when I list at address 2000, I want it in the logic analyzer to see the same data bytes that we see on screen. However, I don't know if Digilant has ever fixed the bug that I found with the Mega 2, where if the address line, if the pattern, if these signals, like up here I have for X address, so I have them listed 15 through 0, but they're not sequential on the logic analyzer header. And so what we ended up having to do on the Mega 2 is we had to, I think it was just, in that case, we just reversed it. Like if I wanted to trigger on address 2000, I would actually trigger on 0004 or whatever, right? Just take the bits and swap and flip them, or reverse them. So that's where at the moment I'm just trying to convince myself that we're decoding, that the pattern trigger is working correctly. Because, like, for example, if I set the address to 2000, I got another idea. And then we say we want to trigger on that. So then I do a list. I'm going to do list from 1FFF just to have some headroom. So if we are in fact able to read from address 2000, we should have triggered. Actually, now I said that out loud, let's just try this. So that'd be 000. So what's 0010? So that'd be 0100. So yeah, so it'd be 0004. All right. Oh, I don't think I believe that. Nah, I don't believe that. I mean, it definitely happened right there, but 4, 8, 9, I mean, that's not enough. Yeah, okay. What was that, 100 microseconds? Yeah, we should have saw. We should have seen a bunch of things, right? This to me just looks like the bits are flipping around. Which I wonder if, what is the, does he say what, this protocol is asynchronous, but I wonder what the, okay, so I'm going to try something else. So in this address, if we add, what do I have the clock connected to right now? 28. Rising, let's go falling. Okay. And then let's reset this to 0. Run the analyzer and do list 1 FFF. Yeah, that, I mean, we should be seeing a boatload of reads if that's what we were looking for. and we're not. So I don't know. I'll have to ask Bernardo if what I'm doing makes sense, because we're definitely not seeing it. Hmm. Hmm. I have another idea. Let me try this real quick, but I have yet another idea. Run. Not export. Darn it. Run. Uh-oh. Oh, list. 1, 1, 2, 3. Yeah, so it never sees that. So here's my next thought. What is at... Let's look for B4 on the address bus. Feel free to lurk. Welcome. B4, F4, FF, B... Oh, that's not even the right address. I don't know how I feel about this. So it should have been like a B4294, something like that. So B4, yeah, okay. Okay, so I'm missing something because we're not getting anything that looks right. I'm not able to capture when we talk to an address in RAM, and I'm not able to capture when we talk directly to a card that doesn't exist. I feel like I'm missing something else. Let's try something. I'm just going to do this, and then let's do 65 or basic 6502. I just want to see if any of these other signals do something. So I just did I'm just printing hello over and over. Well, that's not right. Oh, I just 20 go to 10. All right, run that. That's better. Let's try this. Expand this out a little bit. Yeah, I guess what we need to find out is where in memory is basic at, because that would give me a little bit more clue to what's going on here. What's obvious though is it definitely can tell us when there's activity. Like it's seeing activity. So there's that. But I don't know how to tell. This isn't my first. Oh man, that's what, instead of this is my first rodeo. This isn't my first soldering iron. Yeah, I like that. That's going to be a thing. Okay. I feel like we're almost working. So you missed the beginning, Tim. Right before, I didn't even think to check my audio until 2 minutes before I was going to start. And for years with the old setup, I was trying to find this problem with audio capture, right? And like I had this really complicated, I used to like because I had this really complicated setup. Well, I keep running into the audio issues now, And I finally figured out if I try to use my capture card as an audio device, it's distorted. But if I use the audio on the video channel, which I didn't realize is the same thing, it's fine. But I don't know why. So, oh yeah, 6502 opcodes. Good point. Yeah, good point, Squire. I didn't think about that. So what are some good opcodes? What's the yeah, this one. What we ought to be able to find is a LDA, right? There should be an LDA somewhere, and that's like a 4A, or is that a jump? Holy cow. I don't remember any of these. LDA. No, I want to know what the, it's not what I want. What's A9? A9. Ah, yeah. Thank you. All right, let's at least look for that. And then we can probably, what I'm trying to think is if my, I wonder if my 6502 decoder would work. Okay. So I told it to trigger on A9 and it triggered on A5. Yep, there it is. That's why. Let me try this. Let's add clock to this one as well. No. Well, this can't be right. Or I can't think of a reason why would we get the same opcode twice? Although there's from the same address twice, so maybe. It can't be like a cap though, because it's a 4 input device and all 4 inputs do the same thing. I think there's a driver problem between the card and Windows. Okay, so I know. Okay, now I know what the next thing we need to do is I need to load a program that does something that I know it's doing. So basically, what I want to do. So yeah, the next thing for me to do is write an assembly program that basically chases its tail, because then I know what address it's going to and I know what the opcodes are going to be. And so between those two things, we should be able to determine like if the bits are swizzled the wrong way or something like that. The problem is the Cerberus BIOS doesn't have an assembler. But okay, I know what we can do. Okay, if I can remember how to do it, well, we can just poke those opcodes into memory. So I think I could be wrong, but I think 2000 was meant for program code. So what I want to do is I basically want to how do I do this? It's like I want to load. Don't I want to load the address into the accumulator and then tell it to jump? Or can I just tell it jump to location? 4C is what I was trying to think of earlier. Okay. So I load what's PCL? Okay. So can I just do this? Can I just say, so 4C, can I just do this and say, okay, at, how do I write? You just do it. So can't I just do this? 2000, 4C, 4C, and then, so low byte first, and then, 20, right? So 4C020. Okay. Thanks, Squire. It's always nice to do your homework and then get the answer. Okay, so if I do this, and then I think I can tell this to run, right? If I'm right about the address, I think I can just tell this to run, and it, nope. Okay, let me find out. I might have the address wrong. Memory map. So, it's 205. Okay. Okay. That's all right. So list 205. Oh, see, 205. Oh, I see. 205 is actually already jumping. Okay. Well, so what I want to do is 206, 0, 0x206, 0, and 0x207. No. 205 is 4C. So then I need 0x206 to be 5 and 207 to be 2, right? Because that should be 0205. Okay. And now if I tell it to run, all right, we should be just in a loop. So then if we come to our logic analyzer, I'm just going to say, okay, I'm going to go back to simple. I'm just going to hit single. Okay, so let's just get back to, so the good news is this is completely wrong. Now I'm going to just futz around without even thinking. That looks better. That looks better. And there was much rejoicing. Yay. Okay, so we can actually see it now. So our address is going to 205, then it fetches 206, then it fetches 207, and then it goes back to 205 because it fetches a 4C, a 5, and a 2. We go low byte, high byte. So addresses are 16-bit, even though it's an 8-bit processor. And so we can actually see it now. It's chasing its tail. Now what I want to do, so I had the Indian wrong on the setup here. Now what I want to try and do, I want to take this clock off for a moment and just see what this looks like without it. Same on this one. Come on. Okay. So what I wanted to do this because I want to try to figure out. So 205 comes in, it gets latched. So there's like 2 clocks there versus this falling edge happens once, almost twice. But I wonder if this is because our clock is asynchronous from, I wonder, I'm not sure why are we seeing 2? Is that something the 6502 is doing? So rising edge, falling edge, falling edge, falling edge, falling edge. But this is also, yeah, that's what I'm trying to think is that I wonder if this is just the way that the CPLD sends data to the expansion bus. I don't know. Okay. But now I should be able to trigger on 205, right? And we should see nothing. Nice. Nice. We're still running, right? Yep. All right. And if I go back to a simple trigger, yeah. So the trigger, the protocol trigger still doesn't work. So I'm going to try my trick and just see. So 0205 is 000 0010000101. So then we're going to go 101000000100. Yeah, okay. So that's going to be A040. A040. Okay. Run. Yeah, okay. So this is the same bug I had with the Mega 2. Because it's triggering on 0205, but it's set to the inverse. I don't what's the bit swap of that address. So A040. You know, it occurs to me, I never reported the bug to Digilent, so maybe there's a reason they didn't fix it. Just saying. Okay. So now, if we go back to our thingy and F12 it, and I say to trigger on, what did I come up with before? So if it's 2000, it should be 00004. All right, and then I'm going to do a single because go broke or go home. All right. So we got a trigger. It says at 2000, there's an HC. Interesting. This isn't working at all how I would expect it to. Because it read from 2000 and it got 4C, which is there. And then 2001 is 020. That's what we put in earlier. But I don't, it's almost like, so that's the trigger point. What's the next time we see activity? It's over here. What address is this? It's F833. It just seems like there would be so much more activity than what we're seeing. Okay, I'm going to stay zoomed out. Let's run this again. I'm going to do list 2000. I don't know what I just typed. Is there a way to tell this to stay on top? No. All right. Well, that's a little bit different. All right, so there was 2000 and HC, which I'm wondering if that's even a real read. But then this one over here, that's that F83, F834, 80. So wow, it did a bunch of other stuff before it ever read from 2001, but that's wrong. This should be a 0. So that's not what I think it is. Okay, I got one more idea. One more idea. Did you run into the same thing? Yeah, it drove me insane on the Mega 2, and like Tim even had a script for us that would convert addresses real quick because it was so frustrating to work through that. All right, so here's what I'm going to do. I want to I think I want to do record. I basically want to make use of the history mode because I want to know how many times it sees this address. Okay, well, that was dumb. All right, so one time. Let me try that again. That can't be right. One time. Maybe that doesn't do what I think it does. Okay, so that has to be our read. But then where's 2001? Oh, I hate this. So 2001 is going to be, so that's 0010, and that's 0001, so it's going to be 1000, 00, then 0100. So it's going to be 8004. I guess I could figure that out in my head. Okay, so there's our 2001, and there's the 00, but goodness gracious. Like, I wonder what this thing is doing, because it seems like it is taking a really long time to list memory. Because this is the read we just did. If I come back to this one, that's not it. Oh wait, I just zoomed in on the trigger point. Video refresh. Okay, I didn't think about that. What if that's what it's doing? What if it's reading, what if it does the read from memory and then goes to print it, and then it does the next read from memory and goes to print it, does the next read from memory and goes to print it, kind of like, in a loop. So this is where I would really like to have my state mode logic analyzer, because I would actually qualify out FFFFFFF, because this is pointless, right? Nothing happening here is useful. So I wonder if, where's video, that's what I'd like to see is what was, oh gosh, Squire, you're so smart. So it looks like video memory starts at F800. And okay, let's see if we can't, let me think, how can I do this better? Because this is kind of hard to look at. So this is one place where I really dislike waveforms. I would like to just have a list instead of a graphic view. Just give me the list. And then that way you could like easily filter out this garbage. So 2001, it reads it. And then H1000, H9000, F800. So that's probably somewhere in memory, video memory. And then it writes the 10. Okay, so I want to try something now. So if we go back to 04, arm this, and then do list. Hey, Francois, have a good night. Thanks for hanging out. You make me wish I had SIGROC. And then there's, yeah, okay. I'm not sure. Yeah, at this point, I'm not positive what we're actually seeing, but that's okay, because that's part of the learning. All right. F833. Yeah. So I guess what I was trying to get to is if I would imagine, I was thinking we would sequentially see the F8XX reads or accesses. It's just there's so much freaking time between. And this software has terrible scrolling. All right, so there's our H2000. There's the 4C, and then let's get rid of that. I don't want. Literally, I don't want a marker. Yeah. I mean, I was kind of dogging on SIGROC, but what I really wanted to have, what I had planned to do is make my front end to do the things it was going to do. So there's F833. What I'm wondering is what's 34. If that represents one character. So there's 33, then 34. All right. And then over here, we read from 2001. Oh man, Squire, I think you got it. Because that's our 00. And now what I'm wondering is, are we going to read or write to F835? So slow zoom out, slow zoom in, 36. And then the next one's going to be 37. Oh, maybe I missed. Okay, maybe I missed 35 because there was 36. And then we do, or oh, you know what though? It only printed 0. It didn't print 2 characters. So I wonder if. So what's at 2002 is a 20. Okay, this will be interesting. Well, that might be that might not be true. Okay, so 36. Because what I'm thinking is, what if this is, oh, yeah, so what if this is 33, 34, 35, 36, 37, 38, 39, and it prints a 32, and then are we going to get to 40 on the next access? Nope, 3A. Oh, hex. And it's a 30. So the question is, if I came back to the 36 access, what was its value? Because that should be the same character, the character of a 0. 36 was a 30. All right, all right. So that's what's going on. That's why I was confused. It totally makes sense now I think about it, right? It totally makes sense. So the board is going out. It reads from RAM, and then it writes it to memory or video, or to video memory, whatever. We don't get to see what's going on the video side because we're looking at the data side. So once the character gets written into video memory, who cares, right? And so what we're actually seeing is it reads the value for C, and then it writes 4 and a C, and then it reads a value of 0, and it writes a 0, and then it reads the value of 20, and writes a 2 and a 0 into video memory. And so that's the ping pong accesses that we're seeing. What's crazy to me is the time between. I mean, that is, and I guess because we only get to see the address and data bus on the RAM side, maybe that's why. We're not seeing the video system access the video memory, right? Correct. So it looks like, so the way I understand it now, so this is our read at 2000, and then we write 2 characters, and then this should be the next read. And it is, right? Right. So if we measure that time from here to here, it takes 200 microseconds between each of those characters, roughly, because I'm sure there's probably some differences, but okay. Well, cool. The adapter works. or at least works well enough for right now. Now I gotta wait for somebody to develop something so I can plug it in, and then we can sniff the traffic and see what's going on. But at least for now, I mean, this actually gets us somewhere. So let me save this, because I'm gonna get rid of the data and clean this up. But I'm gonna publish this as part of the documentation for this board, just because I think this would be useful. Yeah. Okay. Let's try one more thing. Now that this is where, now that we know we're capturing data correctly. Oh my God. This one. 3FFFF was going to be FFF. And then what's 3? 0, 1, 1, 1. So it's going to be E. Yeah. Oh, duh. I already knew that. All right. Let's do FFFFE. Okay. Single. Nope. Stop. We're not running fast enough. Single. We're armed. And now I want to write to 0x3 FFFF AA. Darn, that didn't work. Oh. Okay. Hold on. Is it? No. It's C. Yeah, you're right. Because it's 0011, not 0111. And there was much rejoicing. Hey, get it? I really wish I had set that up, but it just happened. Cool. Well, that's kind of fun though. Like, I don't know. It's something. I do have another idea for this computer, just because I think it'd be interesting. I was thinking about making a board that actually does a visualizer for the address and data bus, kind of like I did for the Mega 2. I just thought it'd be kind of an interesting thing that somebody could, like, you could plug it in and immediately start writing stuff to it and see what happens. So 011 is 3 base 1. Oh, yeah. Sometimes I wonder. Sometimes I wonder. So, okay, cool. Well, I'm pretty excited. That's working. I'm happy about that. I still have the other one, which is what I'm calling a 1-to-1, where basically the signals just come out and go directly to headers. So this is probably more applicable for people that don't have a digital discovery. But if you have the digital discovery and a Cerberus 2100, then I've got a logic analyzer adapter for you. I do need to find part numbers for the headers though, so I need to figure that out, because I want to at least be able to say, go to OshPark, get the boards made by this header, or you have to hack it together like I did, since I failed to do that. Okay, cool. Well, this is fun. This accomplished my goal for the night. So probably next week, there's one more thing I want to do with this board before I start making a video on it to talk about it to the world, which I promised the Byte Addict that I would. So I got the programmer for the CPLDs. And so one of the things I would like to do is, just as a exercise, is invert the video or something like that. Do some really minor change to the PLD code and just change it, right? I don't want to go too crazy or anything. I just want to kind of figure it out. The problem I'm having right now is, let me see. Today it's going to work, but watch. I think I said to run it as administrator. Well, actually, that's kind of where I'm going. Is I want to change the palette in the CPLD. Like like, even if I think you can do it in memory, but I want to change the way that, like, I think I may not fully understand how the computer works yet, so this may be complete nonsense, but like I want to say reverse the address lines or something so that when it reads from video memory, it just does something different. Like I don't know, but different but predictable. I don't want it just to trash it because then it's like, well, what's the point of that? But yeah, this doesn't. The last time I tried to load this, so on this computer, loading the project files crashes when couple, but on my other computer, it seems to work okay. So let's just do this one. Nope. So it crashes. So my thought is actually to maybe to use my Windows 7 virtual machine, but yeah, that's going to be tough. I got to figure out how we get that to work. Because like I said, I can load it on my other computer, but I don't think I can compile. But that's a different problem. Yeah, WinCouple is trash. I don't think there's a single person on earth that doesn't think, oh, I'm so glad I get to use this. Like, why can't they just tell us how to do the bitmap? Just tell us how to make the bit stream. Like, just give us the files, right? You know, it's fun. And this is kind of what I was ranting about earlier about, you know, companies don't want to make things open source because then there's an inherent support they have to provide. But this is kind of one of those cases where it's like, I really wish Atmel or Microchip would just give the design, give the information needed to build an open source tool chain. And the funny thing is like virtually nobody would care. Like if somebody could build a functional tool chain for these devices, I sincerely don't think it would cost them anything to provide that information, or very, very, very little. But granted, it's not going to sell many more of the chips, but it would make stuff like this be much better. So anyway, all right. Nothing new lately from me. Last week was the webinar. Maybe next week there'll be a new Workbench Wednesdays video. So, all right, if you want to keep in, okay, actually I meant to do this a long time ago. Oh, that's a different computer. If curious, let's see if the bot responds now. I'm pretty sure I put this command in there. Yeah, we do have to deal with what we get. I mean, fortunately, Microchip hasn't dropped support for the chips altogether, which I feel like is going to happen any day now. So there's at least that. But yeah. Okay, well, Cerberus. If you just search this, you'll find it. I don't know why the bot is being a sleepyhead. Actually, I wonder why. I wonder if I messed up something. Anyway, all right. I'll probably be back next week, and we will definitely be in the lab because there's another soldering project I want to do. I also at some point, and we may work with the CPLDs. I'm not completely sold on that yet, just because I'm not sure. I don't really want to do that on a stream until I can do something useful. So either we'll solder some boards next week or we'll play with this. I don't know. We'll do something fun. All right. Thanks for hanging out. That's the link. Oh, you know, the other link is so all right guys, thanks a lot. Take care. Catch you later. Bye. Also, just real quick, other than the audio problem that I still have to find a solution to, I'm really happy that the new setup works because this may end up becoming a new streaming setup. By the way, I forgot to show this. See, look at this. You can see my brick wall that it totally exists. All right, see you guys. Bye. Oh, I didn't set up that button yet. I'm going to do the fire thing now. There we go.